Expression. So an algebraic expression is a collection of terms made up of variables and numbers that are being added, subtracted, multiplied, and divided. It's an expression. Expressions have no equal sign. Okay. A variable is just any letter or symbol that represents an unknown number. Being, yeah, added, subtracted, multiplied, and divided. Okay, so variables can be any number or letter. Like any symbol or letter that represent an unknown number. Okay, a term. Yes. Okay, a term is a portion of an expression and they're separated by addition and subtraction. Okay. Portion, yeah. So the terms are the parts of the expression that are separated by the addition and subtraction. So they can be multiplied or divided, and they can have, or they can be by themselves, but they're separated by addition and subtraction. Okay. Product is what you get when you multiply two factors. Factors are what you multiply to make a product. I know. And that shouldn't say just two, sorry, it should say two or more. You multiply a lot of things. Okay, if I look at this, this is an expression, it has no equal, correct? Everything underlined in red, these are the terms. These each individual part. And then 2 and x are factors. 4 and y are factors. 3 and x are factors. Any questions about that? Power and exponent are interchangeable. What the exponent and power mean is the number of times a number is being multiplied by itself. Okay, so it's repeated multiplication. The base is the number being multiplied. So if I have, say for example, 4 to the 10th, this is the exponent or the power, and this is the base. And what this actually means is 4 times 4 times 4, 10 4s being multiplied together. It does not mean 4 times 10. Okay. And the whole reason that these were invented, that looks awful. The whole reason that these were invented, exponents, was because it's easier to write 4 with a little 10 over top of it than it is to write out 4 10 times. Or if you had even, like, say, a bigger one. If you want to take something to the power of 30, you do not want to have to write that down 30 times. So it's a shortcut. Okay, yes, bless you. Powers can be worded in a couple different ways. I'm going to kind of do this. So you can either say to the, and then you put in like 4th, 5th, 10th, 20th, 2nd. So it would be like 4 to the 10th. You can also say to the power of. So 4 to the power of 10. And then there are special ones. 2 is squared and 3 is cubed. So if I had 4 and a 3, I could say 4 to the 3rd, or I could say 4 cubed, or 4 to the power of 3. So now if we're going to turn these, we're going to write a verbal expression for each algebraic expression. So I have 3x and a 4, right? So this is 3 times x to the 4th. Or I could also say, like, the product of 3 and x to the power of 4. There's a couple different ways you could to say it. But you can be just very straightforward. For b, I have 5z squared plus 16. So I could say the sum, actually, no, let's not do that. I don't want to confuse you. You say the product of 5 and z squared plus 16. Or you can say raised by 16 or added to 16. I'm going to write an algebraic expression for a verbal expression. Okay, a number t more than 6. More than is addition. Anytime it says a number, it's going to be a letter. So if they give you the letter, you use that letter. If they don't give you, if it just said a number more than 6, you could use any letter you wanted. But so we're going to do t more than 6. You could do 6 plus t, or you could say t plus 6. Either one is fine. 10 less than the product of 7 and f. Okay, so it's 10 less than a product. Now, one thing with 10 less than, it has to be, whenever you see this, it's minus whatever that number is. It's not going to be like 10 minus something. It's going to be something minus 10. Product of 7 and f. 7f. Minus 10, yeah. Okay. 2/3 of, this of is being multiplication. So I've got 2/3 of a volume. So it's 2/3 v. I should probably put the v a little closer. Okay, Mr. Martinez orders 250 keychains printed with his athletic team's logo and 500 pencils printed with their web address. Write an algebraic expression that represents the cost of the order. Now, it doesn't tell us how much of each of these costs, right? So we could call keychains X if you want, and then pencils could be Y, or you could say K and P. You can use whatever letters you want. If I want to find out how much 250 keychains costs, what math am I going to do? Yeah, so I'm going to do 250X, and then pencils would be 500Y, and then the total cost, I'm going to add those together. Okay, so this would be the cost of the keychains, that would be the cost of the pencils, and then all together you add it. To evaluate an expression means to plug in the given values for the variables. And then you simplify the expression.
You were given twice.
Well, I wanted to make you sure you understood that they were given. Plug in the given values for the variables and then simplify the expression using your order of operations. Now there are a couple ways to remember your order of operations. If we go back to when I was in school, we used "Please excuse my dear Aunt Sally." And nowadays they use PEMDAS. Sound familiar at all?
Yeah.
Okay. The P stands for parentheses. And really it's any grouping symbol. So you've got brackets, you've got braces, you've got absolute value bars, you've got a fraction bar, anything that'll separate your problem into parts. So that's first. Second, you do the E, which is exponents. And it's not just exponents, it's exponents or square root, or not just square roots, but or roots. So anything under a radical. Now a radical is interesting because a radical counts as like an exponent in the order of operations, but it can also be a grouping symbol. If something is underneath there that you need to do to it, like adding or something, you do that first and then you take the square root of it. Next, you have multiplication or division. And you do those in order from left to right.
Do we have to write this down if you don't
No.
already?
Okay, so you don't have to go through and do all the multiplication first and then go back and do all the division. As you look at your problem, like the order you'd read in, left to right, if division comes first, you do the division before the multiplication, or if multiplication comes first, they have the same weight. I like to think of it this way. The parentheses are the king, the exponents are the queen, the multiplication and division are the princes and princesses. They have the same, you know, like power. And then last, you get addition or subtraction. Peasants. Okay, so you're going to add or subtract, same thing, in order from left to right. So whichever one comes first. Right, so king, queen, princes and princesses, peasants. Okay, so I'm going to look at this. I don't have any parentheses, but I do have an exponent. So I'm going to do my exponent first. So that's this part right here. So I'm going to have everything else will be exactly the same. 2 squared is 4. The next thing I need to do is the division. So I have 16 minus 8 divided by 4 is 2, plus 14. Next, I subtract, because I came first in left to right order. So 16 minus 2 is 14, plus 14, and then that's 28. We have parentheses, so I need to do what's inside the parentheses first. So I have 4 divided by 2 plus 5 times 4. 10 minus 6 is 4. Next, I'm going to do which?
5 times 5. Oh.
Division comes first in order. Now you can, if you want, you can combine steps, and I can divide and multiply at the same time. So I can say 4 divided by 2 is 2, and 5 times 4 is 20. Yeah, you can do that. And then 2 plus 20 is 22. It's just that you have to do the division and the multiplication before you do the addition. So if you want to do it in 2 steps, you could come down here and say that's 2 plus 5 times 4, and then you could say that that's 2 plus 20. Or you can just do them at the same time. So you can do steps concurrently, it's just that you have to make sure that you do them in the right order still. Here's what I meant by having inside, so I have parentheses inside brackets. So first I need to do what's inside here. Everything else remains the same. Now I'm inside my brackets, I have subtraction and an exponent. I have to do the exponent next. Then I do what's inside my bracket. 32 minus 25, 7. Then I multiply. So you do the inside, you start at the very inside and you work your way out. Here I have a fraction bar. So I need to work the top and the bottom of the problem separately before I do the division. But again, I can do them at the same time, I just have to do them separately. So I can say 2 to the third first, and then I can do also the 15 plus 9 in the same step. So that's 8 minus 5, and that's 24. And then I can do the 8 minus 5, so that's 3 over 24. And then I can either reduce the fraction or I can divide. If I reduce the fraction, I'm going to get 1 over 8. If I divide, well, I'm going to get 3 divided by 24, so I'm going to get 0.125. And these are equivalent, so either way. Wait, an algebraic expression. I've got 3x squared plus 2y plus z to the third, and then it says if x equals 4, y equals 5, and z equals 3. So what I'm actually going to do is I'm going to take this 4 and I'm going to plug it in for x. This 5 gets plugged in for y, and this 3 gets plugged in for z. So this problem becomes 3 times 4 squared plus, parentheses, 2 times 5 plus 3 to the third. So step 1 is to plug in the numbers. Okay, and then step 2 is to simplify, which is actually more than one step, but it's, you know, we're going to simplify from there. So I'm going to do some things concurrently. I'm going to square the 4, I'm going to multiply the 2 and the 5, and I'm going to cube the 3. So 4 squared is 16, 2 times 5 is 10, and 3 to the 3rd is 27. It's 3 times 3 times 3, right? Then I'm going to multiply here, and I'm going to add here. So 3 times 16 is 48, and 10 plus 27 is 37. And then I can add, it's 15, so 85. Okay. Now if that is too many steps at one time, you can break it down and do one step at a time if that's what makes you more comfortable. That would look like this. Or something. So you can do that. It's exactly the same thing. It's just here I did 3 steps at once. Here I separated it all out. So if it's too much to do 3 steps all at one time, you can do 1 step at a time. It's just you're gonna write more. Bless you. Huh? Okay, property of numbers. Reflexive property. I'm not going to write out all the words to the property, but what it sounds like is reflection. Right? Reflexive sounds like reflection. And that's what it is. It's a reflection. So whatever is on this side of the equal is identical to what is on that side of the equal. Now, that could be a number, or it could be an expression. But they look exactly the same. They're in the same order. Everything on one side of the equal and the other side of the equal is identical. So it's a reflection. Okay. Symmetric property is that both sides have the same value. So I could say if A equals B, then that also means that B equals A. So it can either be written like this with numbers, or another example is 2 plus 3 is the same thing as 5. So 5 is the same thing as 2 plus 3. This is symmetric. They're the same value, right? But they don't look identical. They're still equal, but they're not identical looking. With reflexive, they look identical on both sides. With symmetric, they're the same value, but they're not identical looking. Transitive is a transition. You guys know how when you take from one value to another? Okay. You know how if you take like a bus and you have to get a transfer? So you go from like stop A to some stop B to get to your final destination of stop C, but you have to change buses. Transitive property is kind of like that. It's like if A equals B and then B equals C, that means A is the same thing as C. So So like if you know that A is the same as B and you know that B is the same as C, that means A and C are the same. So like a concrete example. 4 plus 1 is 5. You guys agree? And you also agree that 5 is the same thing as 3 plus 2? Yeah? That means that 4 plus 1 is the same thing as 3 plus 2. I'm going to be honest, we're not using this one a lot. Okay, we really don't use this a lot. This one is the one we use the most. Okay? And you use substitution property in your everyday life every time you get change. If you give somebody a $5 bill and they give you 5 ones, they have used the substitution property. If x equals 3, right, then 2x is equal to 2 times 3. We can plug these things in. So we can substitute for this x, we can put 3 in. So this is like, it's replacing. Okay, if I ask you if I could borrow 50 cents, I don't really care if you give me 2 quarters or 5 dimes. Like, you know what I mean? It's the same value. So substitution is replacing with something of the same value. Equivalent expressions are expressions that are equal in value. Okay, so an example might be that two x plus 10 would be equal to x plus 5. They have the same value. We use a lot of identities and inverses. The additive identity, okay, so first of all, let's cross out the word additive here. Identity. What is your identity?
What you are.
What you are, right? So identity of a number is the value of the number. Okay, so that's what the identity is. And the additive identity is the number you can add to something that won't change its value.
Like 0.
Exactly. It is exactly 0. The additive identity is 0. So if I have some number A and I add 0 to it, I still get A. The identity of A did not change because I added the additive identity. And it doesn't matter what number I use. If I pick 1,000 and I add 0 to it, how much does it equal? 1,000. Okay. Now the additive inverse is the number you add to get the additive identity. So that's the number you would add to some number to get 0. Well, what would I add to A to get 0? Okay, let's go to, yeah, okay, I was going to say let's go to a thing. If I said 5 plus what equals 0?
Negative 5.
-5, right? So negative A. So the additive inverse is always the opposite of whatever number you have. So additive identity is 0, additive inverse is opposite. They both have an O. And if you're talking fractions, don't let that confuse you. You just make it negative. These two are additive inverses of each other. If I gave you a negative number, the additive inverse is the positive of it. So it's just change the sign. Questions on that?
It's always going to be the same if it's like the same fraction bracket.
Mm-hmm. So I'm going to go through this with you, but I'm not, here, hold on. We're going to do the steps, so I'm going to do 4 minus 3 first. And that's just subtraction. Okay. Now, if I do 7 times 1, what property is that? I multiplied by 1. It didn't change anything, right? Yeah. And then if I say 5 times 1/5, oops. So I'm going to do 7 minus 1 plus 1. And then I'm going to do these two together because that makes sense to me. And if I did -1 plus 1, it gave me 0 is the additive inverse. So that's plus 0. And then if I get 7, I did additive identity. So that's what the properties are for. That's what they're used for. Commutative property changes the order of the numbers. So if I said 3 plus 5 on one side, it's going to be 5 plus 3 on the other. It just rearranges them. Associative property changes the grouping. Oh, and this commutative property is valid for addition and multiplication. It is not valid for subtraction or division. Okay, same with associative property, changes the grouping of the numbers. So all that would change would be the parentheses. Same for multiplication. Okay. These are obviously really small numbers, they're easier, but the reason this is useful is because maybe it's easier to add the first two numbers together and then add the third to it, because you can do that quickly in your head, versus adding the second two numbers and the first. Or same with multiplication. What if this was like 5? Here, like that. Okay. Well, 2 times 19 is 38 times 5. Do you guys know 38 times 5? Because I don't. But I do know 10 times 19, right? So that's why this is useful, because you can rearrange the group, multiply the 5 and the 2 together first, that gives you the 10, that makes it an easier multiplication problem. Okay. So Eric made a list of items that he needed to buy for a party and how much they cost. We're going to find the total cost of these items. So if I list them in order, this is not very useful. Now I can use the commutative property and I can rearrange things, and I know that 75 cents and 25 cents are going to make a whole dollar. So I put these two together. Okay, so that's, see, 6 and 23 is 29, plus another dollar is 30, and then 14 plus 20.50 is 34.50, and that is an easier problem to do. I was able to quickly put it all together in my head because I rearranged it so that the decimals made more sense. Does that make sense? So that's why commutative property. Using associative property here, I didn't actually put the parentheses in, but I added those and then I added those because it made more sense to group them and add them and then add from there than to go in order down the list. I do the same thing if I do 5 times 7 times 4 times 2. Well, 5 times 7 is 35, 4 times 2 is 8. I don't know 35 times 8. But I know 5 times 2. That's really easy. So I can do 10 times 28, and that's 280. So I took a problem that would have been complicated if I had gone, okay, 5 times 7 is 35 times 4, and then take that times 2. And I made it something that I could very quickly just pop out. That's why these properties, the commutative and associative properties, are nice, is because I can do things like this. I can rearrange the problem and I can group them to make it so that the math is easier. You could ask